Okay, we are continuing to do integration with method of um, partial fraction decomposition with linear factors with the purpose to integrate these rational functions. Okay, so we have the following integral. X to 4 minus 5x cubed plus x squared plus 6x minus 14, all this divided by x minus 4 and x squared plus 3 dx. Okay, before we do anything here, we use the method of decomposition. I would like to invite your attention that the given fraction is improper. To be able to decompose into linear fraction, we need to have the fraction from the very beginning or the initial integral has to be proper fraction. Okay, but in this case we have improper fraction. Why? Because the highest degree in numerator is greater than highest degree in denominator. What is highest degree in denominator? Here we have 2, and if we multiply by here 1, it's going to be 3. So 4 and 3, so which means the fraction is improper. If you look at my previous video, I used there all proper fractions, which means the highest degree of numerator is less than highest degree in denominator. So what do we do in this case? Whatever we usually do in a case of improper fraction, convert into mixed fraction. So the same way we're going to do in this case. To convert into mixed fraction, we are going to use long division. I will place the reference to long division method at the end of this video so you can watch. Let me mark down long division so I won't forget, and place a link or reference to long division. Or you can search on my channel long division, it will come up. Okay, so let's divide. We are going to divide numerator by denominator, right? As we do in a case of improper fraction. So before we do division, I need to multiply this denominator, right? Get polynomial, which is going to be x to 4 minus 5x to 3 plus x squared plus 6x minus 14. Now let's multiply x minus 4 times x squared plus 3. So if you multiply, I'm not going to go slow with this case. X minus 4 times x squared plus 3, I consider that you know since you are doing integral. So it's going to be x cubed minus, okay, x cubed minus 4x squared plus 3x minus 12. Well, if by any chance you won't get this polynomial as a result of multiplication, just ask me right away. It's not a big deal. You might did some silly mistake, which just math and silly mistakes go hand by hand. I do myself silly mistakes, and I am teaching for such a long time, but it has nothing to do with the knowledge, obviously. Okay, so now I can divide x to power 4 minus 5x to 3 plus x squared plus 6x minus 14. Okay, and we are dividing by x cubed minus 4x squared plus 3x minus 12. Minus 12. So first of all, we take this x to power 4, first term, and divide by first term here. And we're going to get x time. Now if I multiply x by this divisor, x cubed minus 4x squared plus 3x minus 12, it's going to be x to 4 minus 4x cubed plus 3x squared and minus 12x. So we need to subtract. What we are going to do, 6 minus negative 12, I'm going to get positive 18 because I will end up adding, right? Next, x squared minus 3x squared, it's going to be minus 2x squared. And here I will get negative x cubed because negative 5x cubed minus negative 4x cubed, we will end up negative 5x cubed plus 4x cubed. Result is negative x cubed. So negative x cubed divided by here x cubed. Result is negative 1. And we are getting, so it's going to be, so I'm bringing down here is negative 14, right? So, and I'm getting 12. Negative 1 times negative 12, it's going to be positive 12. Here it's going to be negative 3x. Here is going to be 4x squared. And plus, and here I will get negative x cubed. Once again, I will place the link or the reference to the long division video. And we are getting negative 26. We are getting plus 21x minus 6x squared. All right, so what do we get from here? We can write down, we got practically the whole number is x minus 1, right? Remainder is 6x squared minus 21x and plus 26. Why I flipped the sign? Because I put in front of fraction negative sign, this one. I put negative sign, and therefore I flip all signs in numerator. Because negative sign in front of fraction we treat as a negative sign in front of parentheses. And we are getting x minus 4, x squared plus 3, and dx. Okay, well, we got some kind of fraction. So now let's break down this fraction into partial fractions, right? Break down into partial fractions. So I'm going to write down 6x squared minus 21x plus 26 over x minus 4, x squared plus 3. We are going to get, let me change the color because I'm doing changes, transitional changes. So before I write down the whole integral, this is gonna be format a over x minus 4. Now look what is interesting here. I am going to have here x squared plus 3. Here is interesting thing. Remember what I'm saying. The degree of variable, I'm not saying x because it can be z, it can be y, it can be any variable. But the degree of the variable in numerator has to be by 1 less than degree of the variable in denominator. Look here. Here I have x to the degree 1. Therefore, I have only a because my x is x to the degree 0, right? Okay. So since here I have, in the second fraction, I have x squared plus 3, I'm going to write down bx plus c, degree 1, right? And it's going to be linear function, right? So in denominator I have 2, in numerator I have 1, by 1 less. So, and it has to be proper. Okay, so from here, what I'm going to do, I'm going to bring to common denominator, right? Multiply. A multiplied by x squared plus 3, b multiplied by x squared, x minus 4. So, here I will have multiply x squared plus 3, bringing to common denominator. Here I am multiplying by x minus 4, x minus 4. Okay. And what do we get here? We are getting a times x squared plus 3 plus bx plus c times x minus 4 over x minus 4 and x squared plus 3. Okay, so if I multiply, open up, and combine, I'm going to get, okay, let's do it. A x squared plus 3a plus, so first thing, bx squared minus 4bx c times x and minus 4c, and divided by x minus 4 and x squared plus 3. Yes? Okay. So combining like terms, this is going to go with this, right? This one will go with this one. And 3a will go with negative 4c. And what we're going to get? Taking x out, x squared out, I'm getting a plus b x squared plus c minus 4b times x and plus 3a minus 4c divided by x minus 4 x squared plus 3. Okay, so let's put it equal to original problem, which is 6x squared minus 21x plus 26 divided by x minus 4 x squared plus 3. Okay, denominator is the same, so I am clearly throwing out a window, and let's compare. I have here x squared, which means a plus b, it's going to be equal 6, right? Coefficient of x squared on both sides. Next, coefficient of x on the left side, I have negative 21. And on the right side, I have c minus 4b. Okay. Regarding available term, on the left side, I have 26. On the right side, I have 3a minus 4c. Okay. we need to solve this now. Let me see what I'm going to combine with what. Well, might as well 1, 2, 3. I'm going to combine A with B. I'll combine, 1 with 2. Okay? So we have A plus B is equal 6. And C minus 4B is equal negative 21. Okay, using first and second. So I'm going to multiply, the first one I'm going to multiply by 4. I'm going to multiply by 4 so I can get 4B, because in the second equation has negative 4B. Let me multiply first. So I'm going to get 4A plus 4B is equal 24, and C minus 4B is equal negative 21. If I add them, this is gone with this, and I'm getting 4A plus C is equal 24 minus 21 is going to be equal 3, right? Okay, well, now I'm going to combine the third one with this new the created equation. So we get 3A minus 4C equal 26, 4A plus C equal 3. All right, so what we're going to do here? I guess I'm multiplying by 4 to get 4C, especially when it's given negative 4C. And we are getting 3A minus 4C equal 26. Now I'm going to multiply everything by 4, 16A plus 4C, and it's equal 12. Let me add this up. So what do I get? This is gone. I am getting 19A is equal how much? 38. And A from here is equal to. Okay. A is equal to. To find B, I'm going to apply to first one. Fill out to first one, because we have A plus B is equal 6. So which means 2 plus B is equal 6, and B is equal 4. This is second one, right? And now to get C, okay, I'll take 4A plus C, this one. And I'm going to get 4A plus C equal 3. A is 2, 4 times 2 plus C equal 3. C is equal negative 8. Negative 8 plus 3. C is equal negative 4. So let's bring back our original integral. Here it is. Copy. So we can continue here. All right. So this is going to be equal integral x minus 1. And what do we have? Our A, we broke down into A, right? Here it is, A over x minus 4 and bx plus c over x squared plus 3. Okay, my A is equal to, so it's going to be 2 over x minus 4 and minus 4x minus 5 over x squared plus 3. Okay, where from I got 4x minus 5? We have here bx plus c, right here. Bx plus c. So our b is 4 and c is negative 5. So we are getting 4x minus 5. And divided by, this is second the part of the fraction, and this is first part of the fraction. Okay? So, and this is dx. All right, now we are going to solve these integrals by substitution. Okay, let's see what we can do here. So first of all, I'm going to break this down, integral. It's going to be x dx minus integral 1 dx minus integral 2 over x minus 4 dx and minus integral 4x minus 5 over x squared plus 3 dx. All right, so first one, x dx, it's going to be x squared over 2, right? Okay, integral of x, it's going to be x squared. Okay, let me do it here. Dx is equal x to n plus 1 over n plus 1. Completely opposite to a derivative, right? N comes in front and n minus 1. Okay, next. Minus integral of 1. 1, we represent 1 dx, that's integral x to power 0 dx, right? So it's going to be x to power 1 over 1, right? Meaning x. All right. Now here it's going to be different story. This negative 2 comes out, and we are going to use substitution. So u, it's going to be equal x minus 4, and du, it's going to be equal dx. So if we plug it, we are going to get du over u, right? And minus 4x minus 5. Let me break it down. Let me see. It's going to be integral 4x over x squared plus 3 dx, and then here is going to be plus, actually it's going to be minus, integral 5 over x squared plus 3 dx. Okay, so what do we have? X squared over 2 minus x minus 2. So let me remind you, integral du over u is equal natural logarithm u, and plus c, obviously. So this is going to be equal, our u is what, x minus 4, so it's going to be natural log x minus 4. Okay, so next we are going to simplify 4x over x squared plus 3. This is what we're going to do. Minus 4 comes out because it's a constant. Actually, no, I will need this 4. Hold on. Let me do here substitution. My u is equal x squared plus 3. Let me move this part here because it's a formula, so we would know. Okay. U is equal x squared plus 3, and accordingly du it's going to be equal to x dx, right? So that's why I said no, we need x, we need these 2 there to squeeze in. So we are going to take out 2, but 2, leave it there, 2x and dx over x squared plus 3, right? So this is going to be our du. Okay, I'll write next time when I go over. Okay, and what do we get here? Second time, minus 5 comes out, and I have integral dx over x squared plus 3. All right, I'm trying to remember which integral in the table of integrals has such integral of the x squared plus any a. So, and if you look at in the table, if you don't remember, you will see that we have integral du over u squared plus a squared is equal 1 over a and arctangent. Okay, let me move a little bit here so we have space. So arctangent u over a plus c. Okay, so we have these 2 integrals, right, to solve 2x dx over x squared plus 3 and the integral dx over x squared plus 3. Okay, so we have the beginning, I am just writing over minus 2 natural log x minus 4. All right, so this is gonna be minus 2x dx, it's gonna be u, right? Here it is. It's gonna be du over u and minus 5 integral dx. Look here, I have x squared plus 3. Here, see, I have similar one, u squared plus a squared. So this 3 is going to be my a squared. I am going to rewrite as x squared plus square root 3 squared. Yes? Okay, so from here we get x squared over 2 minus x minus 2 logarithm x minus 4. All right, it's going to be minus 2 du over u, it's going to be logarithm u, right? And our u is x squared plus 3, correct? So it's going to be 2 natural logarithm x squared plus 3. And here we get plus, because I'm opening this square bracket. All right, so what do we have here? Since I represent it as a squared, this is my u squared plus a squared. Yes, and we have du. So we are going to get 1 over a, it's going to be 5 over square root 3, right? And I am getting arctangent u over a, which is going to be x over square root of 3. Let me shrink a little bit. Oh, okay. And obviously our plus c. Here I noticed something. With this second logarithm, I don't need to put absolute value. You know why? Because we have x squared, so, and then plus 3. So one way or another, it's going to be positive, where there is no chance to get x squared plus 3 negative. Therefore, I don't have to put it in the form of absolute value. I'll just put parentheses, and that's it. So I want to show you another case. I'm not going to solve all the way through. I'll just show you the technique. So when we have integral, let's say, 2x cubed minus 3x squared minus 6x minus 9, and in the denominator we have x minus 1. Let's assume we have x squared plus 5, and we have x plus 1 cubed. So what do we have here? So this way I'm going to break it down. Let's say this thing, this fraction. Let me copy and paste so I don't have to write down over again. Okay. Right? So we need to decompose, right? So it's gonna be equal a over x minus 1 plus b over, we have x squared. So we have x squared plus 5. That's mean what we're gonna do, because remember what I said. The denominator has to have degree by one level 1 degree higher than numerator. Therefore, if I have here in denominator x squared plus 5, in numerator I have to have x to power 1, okay, plus c. All right. Here is also by 1 degree lower, so a x to power 0, while here we have 1. So it's the same thing. Okay. Bx plus c, and x plus 1 cubed. X plus 1 cubed, it's gonna work out the following way. We are going to put plus cd x plus 1, e, we're gonna put x plus 1 squared, because we have cubed. Cubed include degree 1, degree 2, and degree 3, right? Either way it can happen and we don't know which one it is. Therefore, we are including all of them. B, C, D, E, and plus F. And we get x plus 1 cubed. The only reason I am not solving this because it's just too long. Otherwise, you are going to solve exactly the same way. Bring to common denominator, find the matching coefficients. If the coefficient is missing, it's gonna be 0. So you're gonna put 0 and so forth. Okay, so this is, I just wanted to show you what to do so you won't be lost if you see example like that. Okay, said that, I am going to solve next problem. Okay, solving next integral. We have 2x cubed minus 4x minus 8 over x squared minus x squared plus 4. dx. Okay, so first of all, I'm going to, in denominator, x squared minus 6, I'm going to take common factor out. So 2x cubed minus 4x minus 8. I'm not going to put integral because I will start working on it, okay, to decompose. So x squared minus 6, I'm going to write down x and x minus 1 and x squared plus 4. Yes, this is going to be equal a over x, b over x minus 1, and since here I have x squared plus 4, it's going to be, that's right, cx plus d. Okay, now we're going to bring to a common denominator, which means what we're going to have here, common denominator is going to be x times x minus 1, x squared plus 4. So from here, what am I doing? I am taking a multiplying by x minus 1, x squared plus 4, right? Plus b multiplying by x and x squared plus 4, and plus cx plus d multiplied by x and x minus 1. Okay, now we need to find a, b, c, and d. Since if I multiply, it's going to be everything multiplied by each other. It's going to be a long story. So I'm going to go different way. I'm going to use a different method. So, which is, let's say to solve a, I'm going to assign values for x to find this and that coefficient a, b, c, and d. For example, I'm taking x is equal 0. X is equal 0. Then what's going to happen here? 2 times 0 minus 4 times 0 minus 8 is equal 8 times, right? 0 minus 1, 0 plus 4, plus b times 0, 0 plus 4, plus c times 0 plus d times 0, 0 minus 1, right? So what do we have? This is 0, right? The entire this c, this is also 0, right? So here we have practically negative 8 is equal 8 times negative 1 times 4, and plus 0 plus 0. So from here, 2 is equal a. Okay, for b, next I'm taking x is equal 1. Which value to pick it up? You have to figure out, let's say, yourself to make it easy to calculate. Okay, if you put x 0, you figured out a. Then I'm figuring out for b, figuring out 1. You will see it's going to be easy to find out, because if I have 1, then cx plus d times x, x minus 1. So this will become 0. Okay, a times x minus 1, it's also going to become 0. So you have to look and pick the value would be make it easy for you. So what I'm going to get, 2 times 1 cubed minus 4 times 1 and minus 8, right? It's going to be equal. Since a is going to be completely 0, right? It's going to be 0 because 1 minus 1 is 0, and then plus b times, it's going to be 5, x squared plus 4. X is 1, and plus 4, it's going to be 5. You want me to write down? I guess I'll write down so you won't wonder what's happening. Okay, so 8 times 1 minus 1, 1 plus 4, plus b times 1 and 1 plus 4, plus c times 1 plus d times 1 minus 1. And we are getting, this is going to be 0. This is going to be 0, right? And I'm going to get negative 10 is equal 0 plus b times 5 and plus 0. And negative 2 is equal b. Okay, this is another method to find coefficients. Okay, so at this point, we need to determine c and d. Since I have a is equal to, right? A I have is equal to, let me clean this. I already know I'm going to use a and b, that is equal, a is 2, and b is equal negative 2. To find c and d, I'm going to take x is equal negative 1. Okay, and what is it going to happen? On the left side, I'm going to get negative 6. Where is it? This part. It's going to get, okay, let me write down. I keep trying to jump and then pulling myself back. That's okay. 2 times negative 1 cubed minus 4 times negative 1 minus 8 is equal, a is 2, x is negative 1, negative 1. Here we have negative 1 squared. It's going to be 1 plus 4 plus b is negative 2, right? b is negative 2 times x is negative 1. Guys, I'm following this one, plugging data, yeah? Negative 1 and negative 1 squared is 1 plus 4, and then plus c times negative 1 plus d, and times negative 1 and times negative 1, negative 1. Okay. So, and we are getting negative 6 is equal 2 times negative 2 times 5 plus negative 2 times negative 1 times 5, okay, plus negative c plus d, negative 1 and negative 2. So from here we get 2 is equal negative c plus d, okay? All right. And I'm taking x is equal 2 for the d. X is equal 2. Well, obviously a is equal 2. Also we have, let me write down again, a is equal 2, b is equal negative 2, x is equal negative, positive 2, yeah. If you don't like this method, then you can multiply all by each other, and if you have x cubed there, get coefficient x cubed on the left side, coefficient x cubed on the right side. And if let's say on the left side, right side, you have coefficient of x squared, on the left side you don't have any coefficient for x squared, then it's going to be equal 0. Okay? So I'm just showing you method. All right. So then I'm going to have, if I have x is 2, so here, I'm sorry, I'm going to jump already. 0 is equal 2 times 1 times 8 plus negative 2 times 2 times 8 plus 2c plus d and times 2 and times 1, and we get 8 is equal 2c plus d. All right, so I'm going to make system of equation for c and d, and I will get negative c plus d is equal to, and 2c plus d is equal 8. Okay, so if we solve it, I'm multiplying by negative 1 here. So, and I get positive c minus d is equal negative 2. 2c plus d is equal 8. When I add, this is gone, and I am getting 3c is equal 6. C is equal 2. And accordingly, you come, once you plug, you will get d is equal 4. All right, finally. So what do we have? C is equal 2, D is equal 4, our A is equal 2, B is equal negative 2. Okay. So let me copy and paste here what we have. Okay, and now we are going to have here, this is gonna be equal it's gonna be 2 over x minus 2 over x minus 1 plus 2x over x squared plus 4 and plus 4 over x squared plus 4. Let me put it under integral now. Makes no sense to separate anymore. And here we also have 2x cubed minus 4x minus 8 over x times x minus 1 x squared plus 4 dx. Here is integral, and from here we are going to get 2 natural log x, right? And then minus 2 natural log x minus 1. If you look in my previous solution, you will see how I solved it, the same thing. Remember? Plus, here also I will get natural log x squared plus 4. If you wonder what happened to these two, remember substitution we did, x squared plus 4, and then when you take derivative, x squared become 2x, right? So that's where it's going. Or you can go back and see the first problem in this video, right? And the same thing here, it's gonna get plus, oops, twice arctangent x over 2 and plus c. And we are done with this integral also. We solved it. It was a long one, but I believe it will be helpful. Once you understand, I'm solving more advanced ones. Once you understand these things, the easier ones will be piece of pie for you to solve. Because this type of examples include all techniques, possible techniques, okay? All right, next one. Number 3. So we have 8x cubed plus 13x over x squared plus 2 squared and dx. Okay, so what do we have here? Because we have x squared plus 2 squared, so that's gonna include one partial fraction for each power, right? X squared plus 2 squared will include x squared plus 2 to power 1 and x squared plus 2 to power 2. So let's break it down. What do we have? 8x cubed plus 13x over x squared plus 2 squared. This is going to be equal x squared plus 2 power 1, right? And because we have here degree 2, that's mean in numerator has to be x to power 1, which is going to be linear expression, ax plus b. Next, for the second fraction, we are going to have the degree 2, which is going to be, but because we have x is degree 2, so again we are going to have cx plus d. Why I don't count these two? Because if you take it as 2 times 2, it's going to be 4, but not, because this means, this gonna mean x squared plus 2 times x squared plus 2, right? That's why in degrees 2, that's why we take one degree lower and we get cx plus d. Okay, now least common denominator, it's going to be x squared plus 2 squared. Therefore, we are going to have 8x cubed plus 13x. It's going to be equal ax plus b times x squared plus 2, right? Because here we have degree 1, so we need to multiply by only degree 1, right? Next, plus. Here we don't multiply by anything because we have here the degree 2, the full denominator, cx and plus d. Okay, so from here, let me multiply 8x cubed plus 13x is equal ax cubed plus 2ax plus bx squared plus 2b, right here, plus 2b, bx squared plus 2b, and plus cx plus d. Okay, now I'm going to arrange based on like terms. Here we have, this is like term, and this is like term, right? Cx. Okay, so from here we are going to get 8x cubed plus 13x is equal ax cubed plus bx squared plus 2a plus c times x, right, like terms, right? And plus available term is going to be 2b plus d. Yes? Okay. So from here, let's see what we have. I have here 8x cubed, that will match ax cubed, right? Which means it's going to be a is going to be 8, right? Next, 13, see, we don't have here b squared, and I have bx squared. So I'm going to do this and squeeze here plus 0x squared, right? So it's going to be b is going to be equal 0. Okay. And then what do I have? X. For x, I will have this. And which means 2a plus c is equal 13. And we don't have any available term, which means, let me pick some color. Okay, I'll take this one. So 2b, oh, okay, you can't see anything here. Let me choose, blah, blah, blah. Okay, I'll pick this one. So which will be 2b plus d will be equal 0, because our available term is also here 0. We don't have any available term, right? Okay, so since we know a is equal 8, b is equal 0, then from here I can have 13 is equal 2 times 8 plus c. Yes? And from here, my c is equal -3. Okay. And from here, I have my the 2 times my b is 0, right? Plus d, and this is equal 0. So from here, my d is equal 0. Yes? All right. So which means we are going to break it down, and we can conclude that, let me see, where is it? Here we have, let me copy this. So from here, I'm going to write down that integral 8x cubed plus 13x over x squared plus 2 squared, and that is, dx. And I need to put the integral nicely. Okay, and that is equal integral. Here we are going to have ax, so a is 8, 8x, so since b is 0, right? And we have here x squared plus 2, right? Dx, and plus integral. And my c is how much? -3. -3x, d is 0, right? And divided by x2 plus 2 squared dx. Okay, so allow me to clean these zeros. It looks ugly. This 0 sitting there with no sense. Okay, and we are getting, so since I have x squared plus 2, first of all, it's going to be logarithm, right? X squared plus 2. And from 8, we will have left only 4. Why? Because when I take substitute u is equal x squared plus 2, so du it's going to be 2x. So that 2, I will use it. I will have left only 8. And again, I refer to first video. first problem I solved, you will see there. Because if I substitute u is equal x squared plus 2, right, du is going to be 2x. So 8 out of 8 is 2x. I used it. So there is left only 4. And plus, so let me solve it separate, negative 3x, this integral, second integral. I'm going to write down here. So negative 3x over x squared plus 2 squared and dx. All right, first of all, negative 3 taking out, right? And we're going to have x over x squared plus 2 squared dx. Next, we are substituting, we are taking u is equal x squared plus 3, right? Which means du is going to be 2x and dx. So this from here, it's going to be equal negative 3. Since I need to have 2x, right? Let me see. I'm going to squeeze in 2, right? Because I will need this 2x to get dx. Therefore, I'm dividing also by 2 here, right? Adjusting. And here I will have x squared plus 2. Wait a minute, I have x squared plus 2, yeah. Why am I writing 3? No idea. Sorry. Speaking of silly mistakes. Okay, x squared plus 2 squared. So here we have negative 3 over 2 integral, and this is going to be du, and in denominator u squared. So we know that 1 over u squared, right? 1 over u squared, I can rewrite u to power negative 2, correct? And I will get negative 3 over 2 integral u to power negative 2 du. And from here, I'm going to get, so negative 3 times 1 over 2, and this is going to be u to power negative 2 plus 1 over negative 2 plus 1, all right? And we are going to have, where from I use this, because first of all, let me use this one also, because this is also a rule of exponents, and a rule of integral, just in case, x to power a dx is equal x to power a plus 1 over a plus 1, right? And this is under the condition a doesn't equal negative 1, because it will turn to completely 0 there. Okay, and substitute back, we are going to get negative 3 over 2, and we will get x squared plus 2 to power negative 2 plus 1, right? And negative 2 plus 1, which is going to be equal negative 3 over 2 times x squared plus 2 to power negative 1, right? And here also negative 1. So as a result, we are going to get 3 over 2, because negative with negative is going to gone. And since we have x squared plus 2 to power negative 1. So x squared plus 2 will come to denominator. All right. So, and this is, I'm going to write down, let me copy this answer. I'm going to write down right here, right? Right here. And plus c. All right? Okay. Well, since I went over this one in such a detail, let me go over this one also real quick one more time. Okay, so make your life easier. Let me cover this one also real quick since I cover all this. Let me see. I could do it more compact. It's too much, spread it around. Much better. 1 second. Right. And this one also. Okay, this is much better. All right. Since I solved this one, I'll solve might as well the other one also. This one, integral 8x x squared plus 2 dx. So first of all, we are going to substitute. U is equal x squared plus 2. And from here, du is equal to x dx. Okay, so 8 we take out. Hold on, we need 2x dx. So I'm going to leave here 2x dx, and 4 I'm taking out. Okay, and I will have here x squared plus 2, which means what we are going to get, 4, I'm going to get du over u, right? And I will get 4 natural logarithm u, correct? Which is going to be, if I substitute, bring back 4 times natural log x squared plus 2. Okay, as I mentioned, we have here x squared. I mentioned in first problem also when I was solving. There is no way we will get here negative, therefore we don't need to put absolute value. And all we will do, put parentheses. And here we have, okie dokie, I think you have enough. We solved plenty, 3 problems, and they are long at this point. I'll see you in next video. Thanks for watching.